Hello, Professor. This is Catalina, and I'm gonna go over this week's assignment.
Okay, so for the first part, we need to state first a null hypothesis and then 3 alternative hypotheses for the case we were given in the description. So the null hypothesis in this case will be that the hours per day of positive action attention given to children before the age of 7 does not affect their mental health in later years, which means that we are expecting no change in the scores of the mental health psychological test. Because of the positive attention, we're expecting no change. That would be the null. Okay, so the alternative hypothesis 1 will be non-directional, so it will be basically saying that it does have an effect, and it will be in this case a two-tailed test because we are not emphasizing if it is good or bad, or if the scores will increase or decrease. No, we're just saying that we do expect change. So yeah, you can see they're reading it. So alternative hypothesis number 2 will be that the hours per day of positive action attention given to children before the age of 7 positively affects their mental health in later years. So now we're given a direction. This will be a directional hypothesis, and in the positive side or right side of the normal curve, which means we're expecting an increase in the scores of the psychological test because of the positive active attention. And my alternative hypothesis 3 is the opposite. So it means that we are expecting negative effects on later mental health because of the positive active attention. So we're expecting a decrease in the scores. So we'll be looking at one-tailed test in the left side of the normal curve, or the negative side. Okay, so for number 5, a one-tailed test scenario is appropriate when alternative or research hypothesis is directional in nature. Well, yeah, because it has a direction, so it won't make sense to look at both sides of the curve if we're only really looking for one specific side. And a type 2 error is when we fail to reject the null, but in reality the null is false. So yeah, it's basically we get a false null in real life, but we cannot reject it, we fail to reject it. Okay, so the next, number 6 and 7, I just looked at the tables. Here I explained a little bit more where I looked at the tables and why. But yeah, so for 6A it's negative 1.96 and positive 1.96. For B it's negative 2.33 and positive 2.33. For 7 it will be 7A negative 1.721 and positive 1.721, and B will be negative 2.878 and positive 2.878. And yeah, I explained where I looked and why. Now for the second part. So the second exercise wants us to do an ANOVA analysis, which is basically telling us that there's these 3 shifts, and the psychologist wants to see if the number of the 10 absenteeism, so the days the people are absent, the workers are absent from work, differ in those 3 shifts. So to run an ANOVA, we need to find the F ratio, but to find the F ratio we need to find a lot of things before. So we first start finding the mean of each one, and then the grand mean. After that we state our null hypothesis, which will be that there's no difference in the means of days absent per year in between the 3 shifts. So there's no difference, there's no effect in the number of absent days caused by the shift time or shift category. So first we need to calculate
the within group sum squares. To do that, we calculate the square difference for each group, each category, and then we sum them. So that's what I did here, and yeah. After that, we need to calculate the between group sum of squares, which we do by summing the deviations from the grand mean squared times the sample size for each sample. So that's what I did here again. Then we need to calculate the degrees of freedom within and between. The degrees of freedom within are the total number of scores or cases minus k, and k is the number of categories, and the degrees of freedom between is the number of categories minus 1. After that, you calculate the mean square between and the mean square within by dividing the between group sum of squares by the between group degrees of freedom, and then for the one within group sum squares divided within group degrees of freedom. And once you have those two values, you can calculate the F ratio. So you divide the MSB divided the MS within, and we get an F ratio of 0.08. Now we need to find the critical value. We need both our 2 degrees of freedom values and our alpha level. Our alpha level was 0.05, and with our 2 degrees of freedom, we look in the table, the F table, and we find that our critical value is 3.98. So of course we failed to reject the null at a 0.05 alpha level because our critical value, our F ratio did not exceed our critical value. It was far from exceeding it. So and we need to maintain or retain our null hypothesis. So in conclusion, the levels of absenteeism of workers do not differ in the 3 different work environments. That's what we can conclude. Thank you so much, Professor. See you next week. Bye.